This video is it's page 6 of your notes. It's on salts and if they are acidic, basic, or neutral. So, you know acids, like if you see strong acid, if you see strong base, you can tell those. Or you should know, even a weak acid, you can tell. So you can tell those are weak acids probably just by the hydrogen out in front of them. Or you should know that anything with that NH group in it is a weak base. Okay, so you can tell those are acids, those are bases. Hopefully you know that's a base and weak acid. So you can tell those things. But you also have things like salts. Okay, these are salts: potassium chloride, sodium fluoride. So ionic compounds, when they dissociate in water, can sometimes make acidic or basic solutions. And here's kind of your major rule. If you see any of these anions, chlorine, bromine, iodine, NO3, SO4, or ClO3, those ions do not affect pH. Okay, and the reason being, if I put some chlorine ions in water, let's say that they could take a hydrogen from water. Well, if they did, it immediately dissociates again and releases its hydrogen ions. Okay, so this thing does not have the ability to do that. So any of these anions don't affect pH, and these cations, lithium, sodium, potassium, rubidium, cesium, calcium, strontium, barium, those don't affect pH. All other ions do affect pH. So the negative ions of the strong acids, the positive ions of the strong bases do not affect pH. All the other ones do. So if we look at a compound, we go, well, potassium. So when you put this in water, it makes potassium ions plus chlorine ions. So those could react with water to make hydrogen ions or OH negative ions, make an acidic or basic solution. Well, potassium ions are one of these, part of the strong bases, so they don't affect pH. Chloride ions are one of the strong acids, they don't affect pH. This solution would be neutral. Okay, that would be a neutral solution. Sodium fluoride. So look at the first ion. So again, when you put this in water, it produces sodium ions, produces fluoride ions. Well, sodium ions are one of these, so they don't affect pH. Fluoride ions are not one of those. Fluoride ions are not one of these. So this is a weak base. It has the ability to take a hydrogen from water. So I always expect you to be able to write this. I say, okay, if I put this in water, I want to know what happens, be able to write how it acts as an acid or base. So you would write this. Whenever you're writing bases, you want to put it with water. You do the same thing with acids if you want to. This is taking a hydrogen from water, forming HF plus OH negative. So remember, this is a weak base. This is its conjugate acid. The bigger this Kb value, the smaller that Ka value, and vice versa. The sodium ions do not affect pH. Down here we have calcium ions. So calciums are one of the strong bases, so those don't affect pH. And then we have C2H3O2, which is not one of those. So C2H3O2 negative ions. So you got to show how they do that. Well, anions always make bases, so plus water. It's a weak base, so it's in equilibrium. It's not a one-sided arrow. Takes a hydrogen from there, so makes acetic acid, which is a conjugate acid of that base. Again, it's a base because it's making OH negative ions. We look down here. The ammonium ion is not part of this. Chlorine is part of it. So chlorides don't affect pH. Ammonium ion does. Okay, you can either show how this just can produce hydrogen ions. You can put it plus water, or you can just show it making H plus NH3. If you want to put plus H2O in there, you would have H3O plus in here. Remember, it's an acid. It has the ability to give away a hydrogen. Okay, it's a weak acid. So this is a weak acid. This is conjugate base. I know that this is something times 10 to the negative fifth power for a Kb value. That means this is probably something times 10 to the negative, what are we looking at, ninth power for a Ka value. Down here, starts with sodium. Sodium is one of those that does not affect pH. This anion will. So HSO4 negative. Okay, it's an anion, so it's going to act as a base, even though it has a hydrogen in it. So it's going to take a hydrogen from that. And make H2SO4. So if we did this, okay, if we make H2SO4, glad I put this one on here, didn't realize it was on here. If it does that, that makes one of the strong acids, okay? Makes one of the strong acids. So let's think about that for a minute. If it makes a strong acid, that means this is going to dissociate. It's going to dissociate into hydrogen ions, only one, by the way. Hydrogen ions plus HSO4 negative. So if we make hydrogen ions, and HSO4 negative, well, the H plus and OH negatives are going to make water. We'll be right back where we are. Okay? So this does not act as a base. Okay, it does not act as a base. I won't give you one quite like that one. It's a little bit tougher to understand, but that will, since it made a strong acid, it would dissociate right away. A couple others you need to be aware of. Okay, a couple others. There's a list of them on this sheet. There's them on here. So you're just taught these are acidic, basic, or neutral. I will almost always make you write how it acts as an acid or base. So make sure you're aware of that as you're doing things. Sorry about the glare right in the middle, but a couple of these, okay, a couple of these are doing things. So sometimes it's just an acid or base. You know, if you look around here, if you see like that, sulfuric acid, well, that is an acid. It's actually one of the strong acids. Ammonia, you need to know that is a base. Okay, anything with that NH group in it is a base automatically. Okay, this, even though the hydrogen's at the end, this is the acetate ion with hydrogen. That is a weak acid. Okay, so I can kind of tell that. BaOH, okay, it's one of the strong bases. NaOH, one of the strong bases. Okay, H3PO4 is a weak acid. All right, the other things in here are all salts. Okay, the other things in here I think are all salts. So you'd have to try and figure out if they are acidic, basic, or neutral. Something that will happen at times. Okay, something that will happen at times. I don't think I have one on here like this. Something that will happen at times is you end up with like this. Well, this is not from one of these. Okay, so this affects pH. Has a hydrogen to give, it's going to be acidic. This is also not one of those. It's not ClO3, it's just ClO. So that also affects pH. Okay, so NH4 plus and ClO negative both affect the pH. Okay, this has the ability to give away hydrogen. This has the ability to take a hydrogen and make OH negative ions in water. If this is the case, you need to look up the Ka value of this. And the Ka of NH4 plus is 5.7 times 10 to the negative 10th power. And the Kb value of this. They're not conjugates, so we can't just figure it out. We have to look it up. Kb value of ClO negative is 3.5 times 10 to the negative 7th. Since this Kb value is larger than this Ka value, this will make a basic solution. So whichever one has the larger value, the acid versus the base, will determine the acidity or alkalinity of the solution. Another thing that we have not learned yet, positive metal cations, typically ones, we'll just say right now, ones that have a +3 charge or higher become acidic in water. So for example, the aluminum ion, the iron +3 ion, cobalt +3 ion, those are acidic in water. Okay, I won't show you that in this video as to how. It's called a complex ion, but I will show you that at some point in time. But those form acids when they are in water. So if we see one of those, they do make acids. So as we were doing things on there, here's an example of one of those. Okay, it's got the Fe plus 3 ion, Br negative ion. Well, Br is one of these, so that does not affect pH. But the Fe plus 3 ion is one of these, becomes acidic. Okay, again, I'll show you how that works out at some other point in time. Putting through a couple of these, Rb will not affect pH. NO3 comes from one of the strong acids. Okay, this would be a neutral salt. Because you're looking through these, that's how you're going to go about them. If we look at this one, bromine. Bromine is from one of the strong acids. That is not. The NH4 plus ion has the ability to give a hydrogen. That's going to be acidic. KNO2, again, potassium is part of one of the strong bases. That's not affecting pH. But the NO2 negative ion would affect pH. It'd act as a base. All right, so that's how you're going through and doing those. Have a good afternoon and a good day.